Hello friends, welcome here to my channel. This video is part of the playlist Python Basic Programming Beginner's Daily Dose, where I come up with videos on fundamental concepts of Python so that beginner level Python developers will get an insight of how things work behind the scenes in Python. This is part 3 of the video about shallow copy versus deep copy. In this video, I will discuss how to implement copy and deep copy protocol methods for a custom class. If you are not subscribed yet, I will highly request you to subscribe to my channel if you are watching my videos regularly and if my videos are beneficial to you. Like my videos, share them with your friends, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started. Okay, so in this video, I will try to implement a binary tree and also implement the two protocol methods underscore underscore copy and underscore underscore deep copy so that we can use this class we can create shallow copy and deep copy of the binary tree class, and which can be used so that when we call copy.copy and pass object of our custom class, it will create a shallow copy. And similarly, if we invoke copy.deep copy and pass a instance of our custom class, it will create a deep copy. So but before that, I will please note one point that for shallow copy there is a problem with deep copy. If an object, if it's a compound object in Python compound object means an object which contains other objects. So like lists, sets, all the collection objects are compound objects, and also a custom class is a compound objects. So if a compound objects has an object which is basically a reference to itself, then the deep copy might suffer from infinite recursion, because if you make invoke deep copy, that is copy.deep copy, and pass that object, it will try to again create a deep copy of the object which is a reference to itself, and hence it will go into infinite recursion. So deep copy suffers from infinite recursion if a compound object is a self-referential object, meaning it has as internal instance variable or data which is a reference to the object itself. But this problem is not there in shallow copy, because in shallow copy basically all the references are kept in the shallow copy of the original object. I mean, all the references of the containing objects of a compound object, the references of those containing objects are kept in a shallow copy. Okay, so let's now start the code. Now I have written a code for the node class node of the binary tree. It has a very basic constructor which takes the data of the node and left child and right child, which are basically also instances of the node class, and the default values are none, meaning they are null. If you don't pass any right child, left or right child, they will be null. So now, and I've also implemented the representation protocol method so that when you use print an instance of this node class, it will print the state of the node in a very basic form. Now, if a custom class, let's say the for to implement the two protocol methods for shallow copy and deep copy are, we have to implement for shallow copy the protocol method def underscore underscore copy underscore underscore. This is for the time being, let's say I am returning none, and for the deep copy, the protocol method is deep copy. it takes optional memo argument. It takes an optional memo argument which I will not discuss in this video to keep this simple, to keep this content of this video simple and basic. If possible, I will try to address what is this memo in some other future video. Now, for the time being, let's say I return none. Now, okay. So these are the two protocol methods that we need to implement for a custom class, so that it can be used with the copy.copy and copy.deep copy functions. Now, let's first see what if you do not have this implementation. So I'm commenting these protocol methods, and let's see what copy.copy and copy.deep copy does for a class which has no implementation for the protocol methods copy and deep copy. So let me run the Python shell, and let me import the copy module, and let me also import the module of our code. So it's custom class copy as CCC. Okay. Now let's create a instance of node equals to ccc.node. Let's give a data. Now the data can be a simple data like integer, or it could be some other complex, it could other compound data, like it could be list. Compound data means it could be list, set, dictionary, it could be tuple, or it could be some other custom class. Let's say the data is an integer. So let's say 10, the node with the data 10, and we are not passing any left and right child, so there will be none. Okay, so I have this node, and if I just do node, it will print, it will invoke the representation protocol method and show the state of the node. Okay, now let's try to create a shallow copy of this node. So the method is the module copy has the method copy for shallow copy. If we pass the node, we get the node copy, and of course it will look the same, node copy. Okay, now clearly, since the data we have used is 10, which is numeric, we can clearly verify that the node copy data is same as node data. So the shallow copy, the data part, the data attribute of the shallow copy is basically, and the data part of the node copy of the node object are the same object. The node was the original object, and we created a shallow copy node underscore copy from node, and we see that the attribute underscore data of the node copy of the shallow copy and the original copy pointing to the same object. That is why the is operator is returning true, since the data is a numeric data we have used here, 10. Okay, so without any implementation of copy and deep copy, it works. We can invoke copy.copy or copy.deep copy on a class, custom class, which has no implementation of the copy and deep copy, and it will I guess it will work fine, because it will look for all the internal attributes and create a shallow copy or a deep copy of them. Now let's quickly check what if we do a deep copy. Let's say it's a deep copy, and we do a deep copy, and it also works, and we can check it is the same. And of course, in this deep copy, the data part will also point to the same object, since the data we have used is numeric. And for in the previous video part 2, if you have not watched the previous video, I highly suggest you to watch that video, where I have discussed how deep copy, and deep copy works in Python. And if you have not watched even the part 2 one video part 2 one video, then also please watch that video. So here also the deep copy, we see that the data is the data of the deep copy and the original copy is pointing to the same object. Okay, so we see that a class having no implementation of copy and deep copy protocol methods still works fine when we use with copy.deepcopy or copy.copy. Now let's implement the protocol method. I will not do anything. I will just print, let's say, a node copy called just to check that these two implementation methods are being invoked or not, are being called or not. So deep copy called. So inside the two protocol methods, I'm just printing some debugging info. Now let's do again invoke run those code where copy dot node. It is not printing node copy called. Why? It should print. Okay, I guess I have to import again this thing, and let me try. No. Okay, so import copy and import custom class copy as CCC, and if I do node I create a copy of this node. Okay, so we see that node copy called. That means when when we invoke copy.copy and pass the node object, node instance, our copy protocol method was invoked, was executed. That's why we saw the printing node copy called. Similarly, if we do a deep copy, it will should print the deep copy debugging statement. No, why? Node deep copy. Oh, I'm sorry. This should be deep copy plus underscore. Okay, so no. Okay, it's better I will not run code in the shell. Let me write code in the file itself. So let we instantiate a code, we node, give it value data, and then we create a shallow copy, copy node, and then we create a deep copy, and okay, so let's see, let's run the code. Custom class. So we see node copy called, node deep copy called. That means our implementation methods for copy and deep copy are being called. Okay. Now let's implement the copy. Now copy will be a shallow copy. For this, so the the main data part, the main attributes of the class node are data, which could be any kind of data. We should not assume that it will be a basic int or any float or any kind of data. We should write the code generic enough so that it should work fine with any kind of data. So so we have data left and right. So for shallow copy, what we do is we first create of course we have to create a new node object. Node equals to node, and for we will pass the shallow copy. Will have a shallow copy of data, a shallow copy of left, and a shallow copy of right. So we will do copy data. Let's write a little bit clean code. Data equals to copy dot copy save dot data. Only this thing we have to create a shallow copy of data, and we can merely we can straight away pass the reference to the left and right of this class. So left and right, we can do this, and then we return node. So this should work. So we are we are first creating a shallow copy of the data because we don't know what the data is. It could be a simple integer, it could be list, range, or any compound objects like set, dictionary, or even another custom class. So let copy.copy handle that, and then for the left and right of the shallow copy, we are merely passing the left and right references to left and right of this class. So this should return the shallow copy. Now okay, and what about the deep copy? Deep copy for deep copy, let's keep the debugging info as it is. Copy called. Now how to implement the deep copy? Now of course, now there could be various ways, methods we could implement the deep copy. So basically what we have to do is we have to create a fresh empty node, and we have to create a deep copy of the data, and for the data of the newly created node, and also the left and right. The left is also a node. We also we also have to create a fresh left node which will contain all the copies of all the nodes of this class node, as well as we have to do the same for the right subtree. We have to create a deep copy of the right subtree and assign that right subtree deep copy to the newly created node. So what we have to do is first we have to create the data, which will be a deep copy of the data of this object of this node, and for if we for the left part, if we do this, if we let deep copy handle this, I am not sure how this will work. If we do this and let's say node data left and right. So basically we have to, for a deep copy, we have to create a fresh new node, and that should have a fresh data, which should be a deep copy of the data of this node, and also a deep copy of the left and the deep copy of the right attribute. Now if I do this, I'm not sure if this will work fine, how it will work. I mean, since over in this class we are having a self-referential data. self-referential object. No, not self-referential, but it's a kind of the left is also a reference to an object of the same class, node. Right is also an instance of the class node. So this is not basically it won't run into issue of infinite recursion, because left none of left or right is actually referencing to the same uh, instance of this node class. I mean, none of this left or right is basically the same as the self. Here self means the reference to the instance of the node class. Okay, but I would like to I would like to make a helper function to create a deep copy of the left subtree and the right subtree. Okay, so let's first see if this works or not. If I run this, deep copy called. Okay, fine. What is if we print node copy, and if we print node deep copy, what do we get? Okay. What about, let's let's create a small tree. Let's create a small tree hard coded. Let's hard code some code which will create a small tree. Let's create the tree. Let's create the binary tree. Let's say since it's a okay binary tree, let's say we have 4, we have 4, we have here 6, let's say we have here 1, and let's say 2, let's say 3, and let's say 4. This is the binary tree, meaning actually let's say we have this kind of tree. Let's say we are trying to create this tree. So first the root root is 5. Okay, fine. Let's first create the node 1 equals to node 1. We left and right subtree will be none, so we are not passing the those arguments. Let's say node 3 equals to node also 3. Node 7 equals to node 7. Node 2 equals to node 2, and then it will have the 1 as the left subtree and 3 as the right subtree. Okay, and node 6 equals to node 6. It will have the left is none, and the right is node 7. And the root is node 5 with the node 2 as left child, and node 6 as the right child. Okay, so we have the root now contains the root is the binary tree that we have trying to implement. And what here we should use root this will be root, this will be root, and this will be root. So let me see what it prints. So deep copy called how many times? Okay. So okay. So what happened? How many times the copy was called? Copy was called okay, this is copy was called once, because when we did copy.copy root, what happened, it came to this protocol method and node copy called, this was called, and we created a copy of shallow copy of data, which is basically here data is a numeric integer that the here the self.data will be simply returned by copy.data. So and then we created a new instance of node and we passed the data and this and returned the node. So the copy protocol was called only once, but when we did deep copy, how many times deep copy was called? 1, 2, 3, 4, 5, 6. 6 times was deep copy was called. So the first when we invoked a deep copy root, it came to the it came here deep copy, no deep copy was called, deep copy called, okay, then we invoked this won't matter. Now this will perhaps will be a recursive call again with this call will again basically call the self dot underscore left dot deep copy. So while creating deep copy of node 5, it recursively went to the left subtree over here. So another node deep copy called was printed, and while copying a deep copy of this, it came to this node, one node, and again the print node deep copy was called was printed. So so basically node deep copy called should be called n number of times, where n is the number of nodes in this tree and we have 6 nodes in this tree. That is the reason we are getting 6 times node deep copy was called. Okay. So basically it is working the same way, the way I was thinking to implement the helper function. So I guess this is working fine. Now the thing to note is that since the data part is a numeric, so all the data, all the data part of all the nodes in the original copy root will and all the data part of the deep copy of all the nodes, all the data part, the data of all the nodes in the deep copy will merely be a reference to the data of all the nodes in the original copy. Since data is numeric and when you call a deep copy of a numeric data, it simply returns that numeric data. So I think there is no need to implement separately. I was thinking to create a recursive function where it will take a subtree, root of a subtree, and it will create a deep copy of that subtree and return that deep copy tree. But I guess the default implementation of copy.deep copy and is the same. So now we can check that can we check that if the root data is root deep copy data. Of course it will be just to check if we do this, it is returning true. So basically we are checking that the data of the root, that is the root node, which was the original node, and the data of the deep copy of the root node are basically referring to the same object. Okay. Referring to the same object. Okay. What if the data was not was a mutable data? Let's say the data is actually a list of something. So let's say it is actually a list of some integer value and some, let's say it's a list. Instead of using an integer as data, let's say it's a list. It's a list, and now everything will print the same, but the last this should return false, because now every data, since the data of the node is a mutable data in the deep copy, whenever in the deep copy of node, it will also create a deep copy, a separate copy of the data part. So this should now return false. Okay, so return false and everything else is more or less the same. Okay, so this was a very basic basic demonstration of how you can use if you are using a custom class, and if you want to have your separate business logic for creating a shallow copy and deep copy of your class, then you should implement the protocol methods __ copy and __ deep copy. So when you invoke, when you use the copy function of the module copy and pass your instance of your custom class, so it will basically invoke your protocol method, that is __ copy for copy and __ deep copy for copy.deep copy. I hope this video was useful. If you have any kind of question or query regarding this, please do let me know in the comment section. I will do my best to address your question. And yeah, that is all for this video. Thanks for watching, and until the next video, take care and bye.